All right, welcome again to Good Choices. So I've got a few hours here before I need to, oh my God, drive for 18 hours. Okay. So last lesson was lesson 1 of 103.3. Had to only do 18 minutes yesterday. It was just a big time nightmare day. So it's one of those days where like, hey, I did 18 minutes. That's freaking awesome. On a day like that, when it's hard to get things done, if you can do 18 minutes, that's amazing. And I did have a paroxetine yesterday, so that probably was why. All right, so we're moving on to recursive manipulation of files and directories. To manipulate a directory and its contents, you need to apply recursion. Recursion means do an action and repeat that action all the way down the directory tree. In Linux, the options -R or -R or --recursive, so this command's case insensitive because both the lowercase and the uppercase are valid, are generally associated with recursion. The following scenario would help you better understand recursion. You list the contents of a directory, students, which contains two subdirectories, level 1 and level 2, and the file named Frank. By applying recursion, the ls command would list the content of students, i.e. student 1, level 1. Okay, so you list the contents of a directory students, which contains two subdirectories, level 1 and level 2, and the file named Frank. Okay, so you know what? Let's build that out. So we're going to have a directory, and we'll use this using the commands that we learned in the last video. So mkdir students. All right, and then we're going to change directory into students. Now what we could do, and let's do it this way. So we're going to remove that students directory, and we'll do a rm-r. You know what? Let's do rm dir, because that's the one we learned in the last one. So now let's do mkdir help, and if I remember correct, it's -p. Yeah. So this is something I learned in the last lesson. So let's use it. Okay, and then so there's the students, and now we need to do a level. And now we're going to do a space, so we'll escape that. 1. Here we go, and then level 2. All right, let's do the tree command on students. Here we go. It looks good to me. Now we just need one more thing. We need the file. The file is going to be under the students directory. So we can do mk. Now we can do touch students Frank. Okay, tree students. And there we go. So by applying recursion, the ls command would list the contents of students, which would be the level 1 and level 2 directories, and the file Frank. But we would not end there. It would equally enter subdirectories level 1 and level 2 and list their contents, and so on down the directory tree. Alright, so we're going to try it. So let's try that. So it would be ls-r students. Okay, I'm confused here. Let me just try this. So I'm gonna do touch student. And it's relative path. Level 1, and then test. So we got a file named test now. So ls-r. What the hell? Oh, okay. Here we go. So the lowercase r and the uppercase r do something else. Do different things. It looks like the lowercase. I thought it was just for the same command. The lowercase is a reverse. So it's just if we do it without the lowercase. The first file is this numbered file, and the last file is a file starting with W because that's the end of the alphabet. So if we do ls-r, now the last file is the numbered file, and the first file is the file that begins with a letter at the end of the alphabet. So typically they're in alphabetical order, starting from A, and then if there's any numbers or special characters, they go before. But you can do a -r, and they'll start at the end of the alphabet and end with any files named with special characters or with numbers. All right, so that's what the lowercase r does. The uppercase r does what I thought the lowercase r also did. It lists recursively everything within a folder. And now you can see this special syntax here. Is this an absolute path? There's a forward slash. Nope, it's a relative path, because what this dot means is your current directory. And then what two dots means, so like, you know, shoot. So we can do like dot, all project. There we go. It's a directory. So this just means where you are. This means your present working directory. So we can do like cat dot maybe. Yeah. So it's still a relative path. Or is it an absolute path? You know what? It's an absolute path, because this dot is a shorthand. Sorry, it's an absolute path, because this dot is a shorthand for this. So, and then that starts with a forward slash, and then you can do dot. So we can like change dot. And our present working directory is still here because we're specifying it with that dot. We can do two dots and then go backwards like that. Maybe even three dots. Nope, you can't do three dots, just two. All right. So let's do a ls-r on the students. Okay, so now we see each of the files, or sorry, each of the folders. And then within the folder, we see each of the files. Now it's kind of tricky because it's not as clean as the tree command. I much prefer the tree command because you get these lines here that make it very clear that this student contains all of threes, but test does not belong, does not have a parent folder of students. It has a parent folder of level 1. You can see that really clearly with this series of characters there. Here it's not quite so easy to see that. You can say, oh, I must not have anything in the students except for these. Well, you have to read the next part, and you have to know that this isn't cut off prematurely. So I prefer tree, but it probably won't be. You have to install tree from the internet. So like, you know, an old school on the job, out-of-date version of Linux, you got to get comfortable with using these built-in commands. All right, so recursive listing with ls-R. ls-R is used to list the contents of a directory together with its subdirectories and files. So we saw that it does it on separate lines. In the listing above, my directory, including all its content, are listed. You can observe my directory contains the subdirectory, new directory, and the file1. New directory is empty, which is why no content is shown. In general, to list the contents of a directory, including its subdirectories, use ls-R directory name. Add a trailing slash to directory, adding a trailing slash to directory name has no effect. Okay, so it's similar. And I'll put that in there. So, yeah, we can see it did it automatically, but if I were to delete this. But if you do the tab, it adds that in there automatically because you need it. You know, if I were to do students level and forget that, then I'd have a problem. So the tab automatically puts that in there for you because if you want to add more, you need that character there. Okay. So recursive copy with CP-R. CP-R, or now you see it's not quite an or because oh, you know what? Maybe it is. Maybe it is for CP. Maybe it's different. Let's see. Nope, I did that totally wrong. There we go. Okay, so maybe it is different, or maybe it is the same. Yeah, okay, so for CP, there it is a different. It is true that lowercase and uppercase r, when given as options, are equivalent commands. So CP dash lowercase r or uppercase r or dash dash recursive allows you to copy a directory together with its all subdirectories and files. That is a word salad. So it allows you to copy a directory and all of its subdirectories and files, I think is a better way to write that. So here they just magically randomly introducing the tree command. It might have been brought up earlier, but let's keep working with the students directory. So we're going to do tree students, and there we go. So now what we'll do is make a new directory. We're going to call it new. Well, we're going to call it, because like if you're dealing with students, let's think of a real world scenario where you'd want to, okay, so what we're going to do is we're going to say more students. So let's say you had some more students added to your classroom. You know, you'd want to copy in all of the students that were already there. So this is like a real world practical example. So MK, so we did that. Now what we're going to do is copy students into more student. And we can't do that because we didn't specify -r. Now here's the thing, we can do that. So let's do a ls on more student. Oh, no, sorry, never mind. I tell lies on this channel. Just can't do that, it failed. Alright, so now we'll try it again, specifying -r. Oh, same problem. Still similar. Oh, that's because we're not following right along with the example. We're thinking about the real world. In the real world, if you have a directory that contains files and subdirectories associated with students you have, and then say you get a new student, you know, a few weeks in or halfway in, a real world thing you would do is copy over the students you have, and so that when you add the new students, and then you can maintain a record of like who was in the class at the beginning, and then you can look at the timestamp of like when you copied it to see exactly when the new student was added. So lots and lots of real world applications of this. Okay, so the correct way to do this is -r students to more student. Okay, and now if we do a tree of students, there's no changes. And if we do a tree of more students, there are, it's not an exact copy actually. And I'm going to talk about this after I take a quick break here. All right, I'm back. So let's continue on with this enjoyable activity that is not torturous anyway. Okay, so Oh yeah, I want to talk about how these differ. So at first glance, you might think, oh, these are the same, and you might think that especially if you're not using this tree command. Let's see what it looks like with the ls-R. So ls-R, students, more student. So, this is just diarrhea on the screen. You can't really tell what's going on. So, really got to get used to using that tree command. If you can't install a new program on your system for whatever reason, then yeah, okay, this is better than nothing. But it's still not that good. And the other thing is, like, it's not showing you. Oh, you know what? This is actually kind of nice. Oh, wait. No. I was going to say that the what belongs to the more student is in blue and what belongs to the students is in white, but no, the white and blue stands for whether it's a directory or a file. Okay. Okay, so you can kind of see it. More student has students, and then in more students, it has it, and then so you can kind of make it out from there. But this is definitely the way to go. Okay. So yeah, what I wanted to speak to is, okay, we have students. We copied it into more student, which we did here. But there's a difference here. Can you see it? Yep, the difference is that we have the more student and the students file. So what we did is we copied the students directory and everything containing within it to the more student directory. So now we have a path that's more students instead of perhaps what might have been intended, which would be more student with just everything here, and not the students. So I believe the way to do that is, so if you want it to happen in the other way, so let's go into more student. Yeah, and then we'll do a rm -r, and now I'm going to show a special character here. This means everything within. So if I do a ls more student, we still have that directory. If I change directory into it, ls, there's nothing in it because we use that asterisk, which means everything within. So if you wanted to copy everything within, notice that series of words there. So asterisk. If you wanted to cover everything within the students to the more students, you would do this: cp-r students. Now everything within students to more student. So we'll do a tree on students, and now a tree on more student, and they look exactly the same now, except for the name here. So that's an important distinction. I'm not sure if they'll get to that here, but oftentimes when you want to do this, that's not actually what you really want. You want to do this instead. You want everything within the first directory to be copied to the second directory, except for the parent directory of everything within the first directory. You want the parent directory to be the second directory, and not for the files within the first directory to persist the fact that their parent directory is that first directory. You want their parent directory to be changed to the new directory, and to do that you use the everything within character, the asterisk character, and you copy everything within the original directory recursively. So if you leave that out, then if there's any directories in there that have files, they will not get copied over. So you do need that -r still, and then you say the directory you want it in, and now you'll get something that actually you probably intended. In the listing above, we observe that trying to copy my dir into new copy using cp without -r, the system displays the message cp omitting directory my dir. However, by adding the option -r, all the contents of my dir, including itself, are copied into new copy. To copy directories and subdirectories, use cp-r source destination. All right, recursive deletion with -r. It's all the same. I don't think anything is a surprise. So rm-r will remove a directory and all its contents, subdirectories, and files. Warning, be very careful with either the -r or the option combination of -rf when using the rm command. A recursive remove command on an important file system directory could render the system unusable. Employ the recursive command only when absolutely certain that the contents of a directory are safe to remove from a computer. So, what would this do? rm-rf, I'm not going to do it, but it would delete everything, and there's nothing you can do to undo that, to prevent that from happening. If you have users on your system, now that can happen accidentally sometimes too. Like if you're specifying all of your paths absolute instead of relative, you can accidentally do something weird and do that. So the best way is to find a way to ban users from using this, to set up a system where if they try to enter that in, it says, you didn't say the magic word. All right, so in trying to delete a directory without using -r, the system would report an error. So rm new copy. Rm cannot remove new copy. It is a directory. So rm-r new copy. You have to add -r as in the second command for. Okay, so as shown here in the second command, you have to add -r for the deletion to take effect. All right, so note, you may be wondering why we do not use rmdir in this case. There's a subtle difference between the two commands, and I know it without reading. rmdir, it has to be empty. rm-r, it doesn't have to be empty. rmdir would succeed in deleting only if the given directory is empty, whereas rm-r can be used irrespective of whether this directory is empty or not. All right, so add the option -i to seek confirmation before the file is deleted. So you can macro a -i into the system really easily, for all your users on the system. That's probably a good way to do it, because you don't want to, I think it's hopefully safe to assume that everyone on your system is at least some kind of a knowledgeable professional in some way. So you don't want to inconvenience them too much and prevent them from getting their job done. But at the same time, if they're going to do something stupid, you want it not to be easy for them to do that. Let's do it. Oh, you know what? It asks you for every single one. So the system prompts before trying to delete my dir. So this is a good time to demo the pipe yes option. So I can do pipe yes, and then it will just keep spamming y into all of those. So now if I do ls students, never mind. The pipe yes never works the way I think it does. Okay, so maybe you have to put it like this. Oh, you know what? It's probably like this. Yes, pipe. There we go. So yeah, that's how you do it. So um, it automatically selected yes for all of those. So if I do a ls on students, there is no students anymore. Yeah, if somebody's really good on your system and knows how to do that, then all of your precautions won't take effect, which is good because you don't want to, the 20% of people that are doing 80% of the work, probably aren't going to be the ones that make the most stupid mistakes. So if they can get around it somehow, okay, great. What you're trying to do is prevent big mistakes. Okay, so file globbing and wildcards. File globbing is a feature provided by the Unix/Linux shell to represent multiple file names by using special characters called wildcards. What? And I'm interested where the globbing names come from. So I'm going to ask the AI. Okay, so the AI says all shall worship the powerful AI and kneel before it. And actually no, that's not what it says. Let me ask it where the name globbing came from. So where did the word globbing come or originate? Or how did the word globbing originate? There we go. Okay, so the term globbing originated from the use of the glob function. Okay, in the C programming language. Yeah, I don't really know any C, so I wouldn't have known that. The glob function was introduced in the early versions of Unix operating systems and provided a way to expand wildcard patterns into a list of matching file names. The name glob is derived from the term... Sorry, I'm kind of laughing to myself for no reason. All right, the name glob is derived from the term global command, which was used in early versions of the ED text editor. In the ED editor, a global command was a command that affected multiple lines in the file. The glob function in Unix shells expanded the concept of global commands to file matching by allowing wildcards to represent multiple file names. Over time, the term globbing became widely adopted to refer to the process of expanding wildcard patterns and matching file names. You know what? So the term globbing originated from the glob function in the C programming language. It's like Python. Why is everyone saying Python? That's weird. Because there's a programming language named Python. So why are we saying globbing? Because in the C programming language, that's what you call this sort of thing. So we're just calling this sort of thing that from now on. Alright, so wildcards are essentially symbols which may be used to substitute for one or more characters. They allow, for example, to show all files that start with the letter capital A, or all files that end with the letters .conf. Wildcards are very useful as they can be used with commands such as cp, ls, or rm. The following are some examples of file globbing. So rm star, delete all files in current working directory. ls space l question mark st, list all files with names beginning with L, followed by any single character and ending with st. So it's a little bit different than like a regular expression. I mean, it is a regular expression probably, but it's like using a different syntax. So normally in a regular expression, the question mark, I think, I forget what the question mark stands for. It stands for something weird. It stands for like non-greedy, which is like a weird thing for it to stand for. So it's like if you have, I don't know what this question mark stands for, but here, this I would think is a dot. So in a regular expression as I'm used to it. So the question mark kind of serves the same purpose as a dot would in standardized in the form of regex that I know. All right. So RMDIR, A through Z, and everything. Now, this doesn't necessarily mean everything within. It's just remove all directories whose name starts with a letter. It's just a wildcard character. So let's do a hands-on before going to the next section. So I've got all these annoying files, these Melville files. So I'm going to remove them all. And how am I going to do that? RM Melville star. And there we go. I don't have any of those annoying files anymore. All right, so types of wildcards. There are 3 characters that can be used as wildcards in Linux. The asterisk, which represents 0, 1, or more occurrences of any character. The question mark, which represents a single occurrence of any character. Bracketed characters, which represents any occurrence of the characters enclosed in the square brackets. It is possible to use different types of characters, whether numbers, letters, or special characters. For example, this expression open bracket 0-9 close bracket matches all digits. So let's see if we can do a example of that. It looks like I've got this names.csv on there. I've also got a lot of dot files that are kind of like not. I mean, I've got this valid. Okay, I've got a lot of dot files that don't seem to be necessary anymore. I was just using them for examples. So let's get rid of all the dot files. Okay, so how can we do that? We can do RM, and now any character. Now, if we do any character 0 more times, to the dot, or let's test it with an ls. So ls, any file that has any character 0 or more times, and then has a dot, and then after that has any character 0 more times. Do we get all files? No. So here's the files that we would delete. Okay, we delete this one. Do we need that one? Oh yeah, this is when I tried to update the version of GNS3 that I was using. So yeah, we can delete that one. So yeah, here's what we get. We get all these dot files. Don't really need anything like that. So yeah, we can delete all of the dot files on there. So yeah, here's a good example of how you can use these regular expressions. Match any character any number of times. So we're matching here, but then when you match a dot, so we matched a dot. So match any character any number of times until you match a dot, then match any character any number of times. So anything that doesn't have a dot in it, we don't match on. Once we get to the dot, then we match the rest. So any character any number of times until you get to a dot, and then match any character any number of times. So we filter out anything that doesn't have a dot. All right, so let's clean this up. We'll get rid of all that. All right, and we're looking nice and tidy. Oh, the tree is one thing with tree that's kind of nice. You can do a -L, and then you can just print out, you know, however many levels you want of nest station, so you don't have to have that freaking mess. All right, so the asterisk. The asterisk, an asterisk matches 0, 1, or more occurrences of any character. For example, find /home-name **png. This would find all files that end with png, such as photo.png, cat.png, frank.png. The find command will be explored further in a following lesson. Similarly, LPIC-star.txt. This would list all text files that start with the characters LPIC- followed by any number of characters that end with .txt, such as LPIC-1.txt and LPIC-do.txt. An asterisk wildcard can be used to manipulate, copy, delete, or move all the contents of a directory. So cp-r animal. Yeah, and we saw that before in the example where I said all the contents of a directory. So everything within, this is the same kind of language. In this example, all the contents of animal is copied into forest. In general, to copy all the contents of a directory, we use cp-r source path, with the asterisk, so /* space dest path, where the source path can be omitted if we are already in the required directory. The asterisk, just as any other wildcard, could be used repeatedly in the same command and at any position. So rm *ate*. So now the thing is, it's 0 or more characters of any kind. So if it's 8.txt, there'd still be a match. Now if it were te.txt, there wouldn't be a match because it didn't match the character A before it matched the characters T and E, because it started with T and E. All right, so file names prefixed with 0, 1, or more occurrence of any character, followed by the letters ate and ending with 0, 1 or more occurrence of any character will be removed. All right, question mark. The question mark matches a single occurrence of a character. Consider the listing ls. There we go. To return only the files that start with L, followed by any single character. I think the answer is going to be followed by any single character, and the characters st .txt. We use the question mark wildcard. Oh, okay. You know what? I kind of messed up here, or I didn't mess up, but I made this overly complicated. When we did the expression, the asterisk stands for 0 more occurrences of any character. So what we're saying is of any character. So we're matching on any character, and then if we find any kind of character, then we search for 0 more occurrences of another character. Then after that, we search for the dot. So these are completely superfluous. We don't need these. This is the same expression as that was. All right. So to return only files that start with L followed by any single character and the character's st.txt, we use the question mark wildcard. There we go. Only the files last.txt, least.txt, and list.txt are displayed as they match the given criteria. Similarly, ls question mark st.txt output files that are prefixed with any two characters followed by the text st.txt. Alright, so next section is bracketed characters. I'm going to take a quick break and then possibly do some more. We'll see how I'm feeling it. Oh, 40-minute mark, so I'll be back. Alright, let's keep on going. I'd like to get to the hour mark at least. Alright, so bracketed characters. The bracketed wildcards matches. Okay. The bracketed wildcards match any occurrence of the characters enclosed in the square brackets. There we go. Let me try that in the lab. So I'll do the tree command -L1. All right, so we've got file is one. So what can we do? We can do ls and then so any character in the brackets. So it would be fi, then let's try to match both of these and then nothing else. So what we want to match for is f then I, and then we want to match for the character L or R, and then after that any character 0 more times. And there we go. We just got those two files when we did that. Alright, so the bracketed wildcards match any occurrence of the character or characters enclosed in the square brackets. There we go. This command would list all files starting with L, followed by any of the characters in the set AEF, and ending with st.txt. The square brackets could also take ranges. So ls, L, A through Z, st.txt. There we go. This outputs all files with names starting with L, followed by any lowercase letter in the range A to Z, and ending with st.txt. Multiple ranges could also be applied in the square brackets. Alright, so here's multiple language ranges. Let's try that in my home lab. So let's match on my and then we'll do, so we want to match on, we want to get these two files but not these two files. So we're going to do ls my, we want to match on m and y because we want to get all the my's, but we just want to get so there's multiple ways we can do this. Let me see here. So we've got those three. Okay. Maybe this isn't the best to use. But anyway, just, I'm overcomplicating it. Yeah, all you need to do is, we can match for that, and then we can match for, it's not that complicated. Alright, this listing shows a school directory with a list of registered students to list only those students whose registration numbers meet the following criteria. Begin with student dash, followed by a number and an uppercase letter, and end with .txt. So student dash, and then any number 0 through 9. We've got these brackets to know that we're just matching for a single character, matching this criteria. And then the next character we match is brackets capital A through Z. And then this dot is not a like a regular expression where it matches for any character. That would be a question mark. Here we're actually matching for the dot itself. Okay, last section before the guided exercises. Wow, okay, good progress here. So combining wildcards. I need to adjust my posture. I'll be right back. Okay, I am back. So combining wild cards. Wild cards can be combined, as in LS. There we go. And then LS matching P, L, or F. So we would get this P here. We would get all of these L files here, but we would not get this third. And then any character at all. So we're matching. So after we've matched P, L, or F, it can be any character. So H and A are valid characters. But then we're matching for S and T. We don't have an S and T in this file, so all we would return so far is the PST. And our next character is 0 more occurrences of anything. So there we go. This is the file that would be matched against. Oh, wait, I'm confused. Wait, no. We would get everything except for this, because we would get P, L, or F. So we've got L's here, not a T. So we would get all 4 of these. Then we would get any character, so A, E, I, or A. And then we would get S and T. They all have S and T. Yeah, and then anything that comes after that. So yep, we get these 4 files, but we wouldn't get this one. The first wildcard component, bracket PLF, matches any of the characters PL or F. The second wildcard component, question mark, matches any single character. The third wildcard component, asterisk, matches 0, 1, or many occurrences of any character. So LS, there we go, and there we go. The previous command displays all files that begin with the letter F, followed by any set of letters, at least one occurrence of a digit, and ends with .txt. Note that the file.txt is not displayed, as it does not match this criteria. Alright, guided exercises. Oh my god, this is amazing. So consider the listing below. There we go, ls-lh, so the -l, we get the long listing, and then the -h, we get the human readable file sizes. What does the character D represent in the output? It represents the difference between a file and directory. So characters with the files, because everything's a file in Linux, with the D are of file type directory, and then the files without the D are just basic files. So why are the sizes given in human readable format? That's because of this -h right here. What would be the difference in the output if ls was used with no argument? So we would not get it looking nearly as neat. We would just get in alphabetical order each of these listed. So they'd be in the same order here, but they would be in columns and rows instead of just in a single row. They would be in multiple rows, and they would be in multiple columns. Here they are in a single column with multiple rows. The difference would be that they would be in multiple columns. All right, so let's see what the official answer is. What does the D represent in the output? The D character identifies a directory. Why are the sizes given in human readable format? Due to the option -h. What would be the difference in the output if ls was used with no arguments? Directory and file names would be provided only. All right, guided exercise number 2. Consider the command below. All right, I've considered it. What would happen to the file emp_name if this command is executed successfully? So the file emp emp underscore name would be copied to, and assuming this is a directory, I don't even know, but it would be copied to this directory. So it would exist in both the Frank directory and the Frank backup directory. If emp underscore name was a directory, what option should be added to CP to execute the command? Dash R, we saw that, dash lowercase r, we saw that multiple times. With the CP command, it can be dash uppercase r as well, or it can be dash dash recursive. All right, so if CP is now changed to MV, what results do you expect? Totally different results. If it's MV, then if this is a directory, then it will cut it from here and move it to this directory, so it will no longer exist in this present working directory. Now, if both of these are files, what it will do is rename this file to that, and then this will still be missing. So anytime you move MV, you're blowing away this side of the command, and you're just having it exist via the second argument. All right, so let's take a look at the official answer for that. What would happen to the file emp underscore name if this command is executed successfully? Emp underscore name would be copied into backup. If emp underscore name was a directory, what option should be added to CP to execute the command? Dash R. If CP is now changed to MV, what results do you expect? Emp underscore name would be moved into backup. It would no longer be present inside the home directory of user Frank. Perfect. I feel like the difficulty in this learning material is like all over the map. Like this stuff is really easy. It could just be because I'm, an advanced Linux user. So like I know a lot already coming in. So it's like, of course, like what I know is easy and what I don't is hard. So maybe the order of difficulty is actually pretty good. All right, so consider the listing ls. Which wildcard would help delete all the contents in this directory? So the asterisk, you do rm. You don't need the dash r because there's no, assuming you could have a directory named this name, but I think it's a fair assumption that these are all files of file type, not of directory type. So it'd be rm star, which is another word for asterisk. All right, official answer, please. Which wildcard would help delete all the contents of this directory? The asterisk. Next question, based on the previous listing, which files would be displayed by the following command? So, okay, well, let's look at these. So, ls file, file, yep, they all have file, so they'll all match. Now, 0 or more instances of any character at all, 1, 2, 3, and 4 are all a character, so match all those. .txt. So it would display all of the files. All right, so complete the command. Oh, this is number 4, so we can look at the answer to that. All of them, since the asterisk character represents any number of characters. Yeah, this is like really easy, especially if you're from a Python background. It's like, it's not difficult. But I could see how it's difficult for some people. So hopefully those kinds of people are helped by this channel. That's what I'm here for. So complete the command by adding the appropriate digits and characters in the square brackets that would list all the content above. So here we go, ls. Now we gotta, okay. So all the content above. So this here is all the content above. So we could add 1 through 4. And let me try that because I'm not sure if it's including or if it's up to in Python. Let me do that here. So if we were to have the same thing, so if we wanted to match all these files, so let's say we had a list of files. So we'll say files equals file1.txt, file2.txt, file3.txt, okay, file4.txt, Okay, so there we go, end bracket, there we go. So now if we do for file in files, and we say, let me see here. Let's import re, so regex. Yeah, and now we do for file and files 234 re dot find, and then the regular expression is going to be, so we'll use a raw string for that. It's going to be and I'm using Python 2, which is bad. So let's see here. So the regular expression will be file, and now if we do 1 through 4, let's see if we match on 4 or if it's up to but not including. And then .txt. There we go, and we're gonna match on file. Oops. Oh, and then we're gonna print. Wait, I have to. Oh. Search. Okay, so we're gonna say match equals, or that's search, and then we're gonna say print match dot group 0. Okay, you just have to kind of trust me that that's how you use the RE module, and you know I tell lies on this channel, so there's probably a better way than that. But yep, it's not up to but not including. In this case, let's see if that's also true for the ls command. So we're gonna create some files. Let's go into experiments. We'll create that directory, and then move into it, and then we'll create some files. So we'll do touch file. Now let's see if we can do this. 1 through 4. That would be awesome. .txt. Nope, can't do it. All right, so touch file 1.txt, touch file 2.txt, 3, oops, and file 4. All right, so just a regular ls gives us all of those. So now what command to would list all of the content above? So so to list all of this content using that syntax, we would use file 1 through 4. Now I'm not sure if it'd be 1 through 4 or 1 through 5, because we don't know if the last digit is up to but not including. We saw in the Python regular expressions it is up to and including instead of up to but not including. So let's see what it is here. All right, so here it is up to but not including, up to and including, sorry. So if we add a 4, no error, no anything like that, because there just isn't a match 4 or 5, so it's not a big deal. And then if we change it to 3, now we won't get that file 4 because it does not match the criteria. All right, so let's see what the answer is. The what? Okay, so complete the command by adding the appropriate digits and characters in the square bracket that would list all the content above. Okay, so I mean, this is just one answer. Yeah, you could do 0 through 9. That will list all the content above. Great. There's nothing wrong with that. You know what you could also do? Nope. Nope. Okay, well, you can't do that. But, yeah, that's just kind of silly. Like, you know, there's 2 ways to do it, and I hope the exam's not like that, where it's like they ask you this question and it's like they're not asking you to be a human and think. What they're asking you to do is puke out, you know, what you learned in some obscure material that's not necessarily here. So if you're a human and you like to think, your answer is going to be 1 through 4. If you have nausea and like to throw up whatever's in the textbook, then you might put 0 through 9 and get full matching later when it needs to be more precise than that. All right, so those were the guided exercises. I don't see the Oh, sorry, we're in the answers. So let's move back up to the questions. There we go. That was the final question of the guided exercises. So we're going to move on to the explorational exercises, and I'm going to pledge to just finish this out before I hit the road for for 18 hours. So I might do some more in like my hotel room on my laptop or anything. The audio will be garbage, but it's been worse. So, and I'm bringing my Jabras, so it shouldn't be that bad. So, I'm gonna come back though and finish up this whole section before I leave. So, but I need a break, so I'll be back and we'll finish up this section. All right, welcome back. So I'm kind of running out of time here. Would have liked to leave around 10, but it's 18 hours, so a few hours here and there doesn't make that big of a difference, especially since I'm just gonna get a hotel and I need to arrive in kind of later anyways, because the hotel I have booked, check-in is late afternoon. So, I'll roll in around, if I do like 9 hours today, 10 hours, and leave the rest for tomorrow, that'd be fine. And just the kind of person I am, if the road is clear and everything's peaceful and nice, I'd rather just keep driving. So I might be up super late tonight anyways, so it doesn't really matter for me to go until 12, maybe even 1. 1 might be a little late. But anyway, these are the explorational exercises. So in your home directory, we're going to create files called dog and cat. All right. And I'll blow away this experiments file. Oh, look at this. You can do L and get that. You can also do LL. That's usually a macro. If it's not a macro, I do recommend setting that up because ls-al is 5 characters, kind of not super cool. LL is just 2 characters, and that long listing of the contents of your directory is what you're going to need to be looking at like more than half the time anyway. So I do recommend setting that up. You just have to hit the L twice instead of even needing both hands. All right, so this is my home directory, present working directory there. If I change directory, it's the same present directory. CD to the shortcut for home, it's the same present directory. So we're going to create some files. The first one is going to be dog. So to create an empty file is touch. All right, and then we'll create another one named cat. All right, and let's remove those files and create them using the special syntax here, where you can create 2 files just using a space. All right, so there we see the 2 files, cat and dog. Still in your home directory, create a directory called animal. All right, so we do mkdir to do that. animal. All right, and then we're gonna move dog and cat into animal. So we do not want them to persist in our home directory anymore. They're only gonna be in animal. So we're gonna use that special syntax again. We'd say mv cat and dog. All right, so we don't see, we do see cat. I guess that special syntax doesn't necessarily work in this case. Let's take a look at what's in animal. Okay, there's actually nothing in animal. What the? Oh, okay. You know what we did? And this is a good lesson too. This is a really good lesson because anyone learning this is going to do this sort of thing all the time, like I do. And I consider myself, I'm ready to work in Linux. Like, it's not, I'm just getting this cert because I want to validate my existing skills, not because I want to learn it from scratch. So, you know, you're going to make these kinds of mistakes all the time when you work with Linux. What I did is I renamed the cat file to dog, because there is no dog directory. There's just a dog file. So the let me do it again. Let's do echo. So first we're going to create the cat file again. Then we're going to do echo meow into cat. Okay, and then if we cat, we see meow, and then let's echo bark into dog. So now if we cat dog, we see bark, and then let's do that command again. Move cat into dog. Okay, and now let's do an ls, and we don't see cat anymore, so we'll do an ls cat. Nothing, no such file or directory. Now let's do a cat dog. And it now says meow instead of bark. All right, so let's start over again. We're going to remove dog. And then we're going to, we already have animal. So now we're going to start all the way from the beginning. We're going to create a file called dog. And then just in 2 lines, we'll create a file called cat. If you're from a Python background like I am, this idea of doing everything on 1 line and, you know, saving steps, and it's just like, you know, that's one way you can do things, is to condense it down into, you know, 1 line and spend 2 days trying to come up with the fewest line way to write something. Or you can get the job done and move on. Like, sometimes the easiest way of doing it is the most readable. It's like touch dog, touch cat. Okay, you've got 2 files, one named dog and cat. Like, if you do it in any other way but that, all you're doing is serving to confuse the next person that comes in and reads the code. So clever coding, in my opinion, because I come from a Python background, isn't as important as working code. That's the only thing that's important in my mind. That can work across time, meaning that somebody can come back to it, and if it stops working due to some sort of update, make the changes that are needed. That's basically, from a Pythonic background, the only thing that really matters in my mind. Okay, so this is a perfectly valid way to create 2 files. Next, we're going to move both of these files. So we're going to do the mv dog into animal. And we can do that because we're not renaming the file in this case, because animal exists as a directory. There we go. And we'll do the same with cat. There we go. And let's do an ls. We don't see dog and cat anymore, so that's good. And then let's do a ls dash capital R on animal. There we go. And now we can see kind of similar to a tree output. We can see that dog and cat belong to the animal parent directory. Let's say, now go to the documents folder found in your home directory. So cd doc. I do not have a documents folder. I do not have a documents folder, which probably makes sense because this is like a home lab. And create the directory backup. You know what? Let's just create a documents folder. So mkdir documents. Okay, we're gonna move into it. All right, and now we're gonna create a directory named backup. mkdir backup. Okay, and then we're gonna copy animal and its contents in the backup. This is a great lesson because a lot of people, I think, will fail at this lesson because they're not conscious of their present working directory. So if you try to just say, okay, so let's copy animal and its contents into backup. Okay, animal. Oh, it's not auto completing. What's going on? Something's going wrong. So animal, and all of its contents. So we can either do it. So we can do a -r. Oh, but what's happening? Sorry. There's no, so we use the dot to specify we want it in our present working directory. But what's happening? ANIMAL. And that's spelled correctly. There's no such file or directory. Well, that's a lie. We see it if we go back one level. We do an ls. Here it is. So if we go back into the documents and we run this command, it's lying to us. We see it right there very clearly. There is the file directory. What is happening? Why can't it read it? Well, we're giving it the path relative to where we are. So we're saying inside of this directory, we have another directory named animal, but we don't. So the relative path that actually contains this file, you can specify with a ... like this. Now it's relative to your current path, so you can't do something like, for example, gposh /animal, because it's gposh is not relative to this path. Like the parent directory is documents, and inside of that directory does not exist gposh, even though gposh is the parent directory of documents. So if we were to do this and then do a dot, still no thing. So one thing you could do is specify a absolute path, and you can do that with this macro here. Another thing you can do is specify a relative path using the macro. And you know what? This is probably an absolute path macro. I'm not sure. I think it would actually have to be. So yeah, so you're specifying an absolute path here. You can't really use a relative path in this case because there is no path relative to your present working directory. You can't go upwards in specifying a relative path as far as I know. You can only go downwards. All right, but let's do this. We're going to copy animal and its contents into backup, and we're going to do it from this present working directory. So what we do is copy -r, to use uppercase or dash recursive, whatever we would like. I'm going to use uppercase. I'm going to specify the directory prior to this one, animal, and then specify this current directory. There we go, and we've got the backup folder. Let's do a tree. And there we go, inside the backup folder. Oh, you know what? I did this wrong. Okay, so let's delete the animal. Okay, clear tree. Okay, so we're back to where we were. We created the directory backup. Now what we need to do is fix the command. We don't want to do it into that present directory. We want to do it into backup. Okay, so there's the answer there. So there we go. Copy and its contents to backup. Perfect. Now we need to rename animal in backup to animal.backup, and I believe might need a -r on there to do that to a directory. I'm not sure. Let's see. All right, I don't see a -r. I do see a -t, but I believe it's a yeah. You know what? We don't need. What we need is a you don't need a -r. So let's rename animal in backup. So we're going to do mv backup because we have to specify the path. In this case, we can specify a relative path because relative to our parent directory, it is a child directory. If it were a parent directory of our present working directory, we'd have to use the ... symbol. If we were in a child directory and it was more than one, branch up, if we were in a child directory that was not the direct child to the parent directory, so that we could not use the dot dot symbol, then we have to specify a absolute path, as far as I know. All right, so we're going to copy the. We finished that, so we're on step number 5. We're renaming animal. There we go. So let's rename it in backup. That's where we're working to animal dot bkup. And when I said that's what where we're working, wrong. We're working in /documents. So that's why we have to specify this. If we were working in animal, then we would not have to specify this. If we were working in backup, we would not have to specify this. If we were working in animal, we might have some issues renaming it because we're existing in there. So you know what? I'm going to try that. Okay, so now I'm in the folder, the directory that I'm trying to rename. So, I can't specify it because I'm in it. So like there is no, within the directory animal, there is no directory named animal. All right, well, let me try this. Okay, that's valid. And we'll rename it to animal, and we'll name it to animal dot bkup. Okay, that's perfectly valid. So right now we are in the animal, but if we go back, now we've only got animal. So it exists insofar as you are still within it, but the moment you leave it, that's when that command like actually takes effect. Now, one thing I would like to see, which would be really interesting. Let's open another session. Okay, perfect. And then what we'll do is that same thing. So we're gonna go. We're gonna just stay where we are like this. Then we're gonna go over to documents. Documents backup. Okay, and now we see that animal.bkup. So now let's do the same command. Okay, but we're gonna do the we're gonna change it back. So .bkup back to animal. There we go. We're still in animal.bkup. So let's see if that change went into effect. Yep, it went into effect already. So even though we're still in it, this is just temporary and a script or like another user. We'll see the change as soon as you issue the command. Now, I make a point to do this because in a lot of networking gear, that's not the case. The change is only made after you do something like this. You move out of the subsection where you make the change. In this, that's not the case. You see the change immediately as it is issued, even if the original name of the file temporarily exists due to you being within the original name of the folder is temporarily still existing because you are in that folder, which is interesting because I wonder what happens like when you create a file. I mean, this is kind of like, this doesn't matter, but like, wait, what's going on? Oh, okay, yeah, I'm in the wrong. Oh, and I have to be in the wrong one. That's like exactly, that's what I'm demoing. Okay, so I exist in this folder that doesn't exist. So we can see that here. What happens when I create a file? So lion. Okay, we can see it there. So what does this look like for now? Yep, so it has the file. So it just doesn't back propagate the change. like you're still working in this even though it's wrong. So what I would recommend is like after you do that, just make sure that your present working that the change you're not in the present working directory, and yeah. So this sort of thing, this is more like a computer networking channel. So like on Cisco gear, on Juniper gear, on a lot of gear, you have to make the changes in the subsection you're in, and then the changes won't apply until you leave the subsection. But this operates differently. Once you make the change, whether you're in the subsection or not, the change is made. If you remain in the subsection, if you were in the subsection and applied the change to the subsection will persist as a prompt, but everywhere else persist in your bash prompt, but everywhere else on the system it will be made. And then once you leave that subsection, it exists no more. All right, so we did that. The home /LPI/databases directory contains many files, which includes these files. Which single command can use to list only the files mentioned above? So let's take a look at what that's like. Okay, so we're going to list only the files. So let's see what's in there. Home, LPI, database. Oh, I do not have that. Yeah, I think this is an exercise, depending on like maybe they have a lab that they give out as part of this, but let's just think about it. So the command to list the files, ls. Now to list only the files mentioned above, so we want to match on db dash because each of these files have that, and then we can do a bracket. And in the bracket, we can have 1-3. That way we're matching 1, 2, or 3. And then after that, we can have a star. You know what? And let's not have a star. Let's just specify everything there because there may be unzipped files. There may be false positives with the star that we wouldn't get if we just specified it. So my answer is db dash bracket 1 through 3 and bracket .tar.gz. All right, so let's take a look at the, these have been pretty easy so far. Let's finish them out before we look at the answers. So consider listing ls, there we go. With the use of a single globbing character, what command would remove only the PDF files? So a globbing character that comes from the C language. It's a character. It's kind of like a regex. It's what we did here. The globbing characters are, they're not regex expressions. They're globbing characters. So bracket 1 through 3, those were all globbing characters. So here we can only get 1. So what we could do is *.pdf, and then we're just using 1 globbing character. All right, so let's take a look at the answers. All right, so the answers to the explorational exercises: in your home directory, create the files dog and cat. We were able to do that with the syntax where we separate them by a space. And then still in your home directory, create the directory called animal, move dog and cat into animal. So here we go, we made it here. Now we moved dog and cat, and they use a special syntax here. This is kind of what I would call unpythonic. You could just do it all on separate lines. There's no real disadvantage to having more lines in code, in my opinion. So here's what they do, and they didn't rename dog to cat because they added this -t. And let's take a look at the -t quick. So what the -t means is target directory, move all source arguments into the directory. So we know not to rename these, and we know to move both of them into animal because we're using this -t here. And this is just one way to do it. There's multiple ways to do it in Linux. In my opinion, a perfectly valid way to do it is to split this up into 2 lines and don't use the -t, just do dog animal. And another way you can tell it's a directory is this will be automatically inserted after directories, but not after files, because there's nothing after a file. The files don't contain more files. They contain the contents of a file. Directories contain files. So to move to the file path, you would use this sort of syntax here. You would never use that kind of syntax for a file itself unless you named it this, but if you did, then shame on you. That's ridiculous. All right, so go to the documents folder found in your home directory, and inside create the directory backup. cd documents, make your backup, copy animal and its contents into backup. So copy -r animal. This is what we did. This is what we did. Yep. And then -r. Yep. This is what we did. So rename animal and backup to animal.backup. We did this as well. You don't need this. It's optional. Nice to have though, because it gives you that clear sense that this is a directory. But here we're renaming. We're not using -t, anything like that. So it automatically knows that these are directories, which are, a form of file in Linux. So we don't need any special characters to signify it as such. And we are renaming. So the /home/LPI databases directory contains many files, which includes all these. Which single command can you use? There we go. Got it. Got the answer correct on that one. So the next one, consider the listing. ls, there we go. With the use of a single globbing character, what command would remove only the PDF files? Got this one as well. rm *.pdf. The previous answer was db *1 through 3. So one big takeaway for me is I know regular expressions in Python, and I'd be tempted to say that what we learned here was regular expressions, but we got to be careful not to say that, because regular expressions are different in major ways. What we learned here is globbing. All right, summary. In this lesson, we explored how to view what is within a directory with the ls command, how to copy CP files and folders, and how to move MV them as well. We also looked at how new directories can be created with the, I think they mean directories there instead of directories. Although I wonder if you move into a computer's directories, if that might make the computer well, let's not think about that. Let's keep moving on. So we looked at how new directories can be created with the mkdir command. The commands for removing files rm and folders rmdir was also discussed, well, removing empty folders. In this lesson, you also learned about file globbing and wildcards. File globbing is used to represent multiple file names by using special characters called wildcards. The basic wildcards and their meanings are listed here. The first wildcard is a question mark. It represents a single occurrence of a character. The second wildcard is square brackets. It represents any occurrence of the characters enclosed in the square brackets. The third wildcard is an asterisk. It represents 0, 1, or more occurrences of any character. You may combine any these. They're missing of, any of these. You may combine any of these wildcards in the same statement. All right, we made it. I'm very happy I made this. So I'm gonna hit the road, and tomorrow or whenever I get to it, we'll go on to lesson 2 of 103.3. All right, so thanks for watching, and see you in the next one.